Hi, welcome to another video. So today we're going to be looking at a whole bunch of different strings of Christmas lights. We're going to do a little mini shootout here, comparison, whatever you want to call it. And I got a bunch of different light sets from several manufacturers, and we're going to go through and measure how much power they use. We're going to do a kind of a rough light output measurement. We're going to look at the light waveform, and we're going to measure the current. So some of the things that happens with some of these Christmas lights or Xmas lights or holiday lights or whatever you want to call them, fairy lights. Some of the things that happens with these lights is they flicker, and people notice that. So we're going to take a look at several of these different sets. Some of them are incandescent style, some of them are LED style, and we'll see how much flicker we see between the various different options, and we'll see which one's the best. So first thing, we'll open up one of these sets and plug it in and see what we get. So starting out here, we have a 100 LED set. It says colored lights. This one just came in a bag, really simple. So you can see it just comes kind of wrapped up. Looks like there's just a twist tie on there. It does have an extender cap here. This is one of the newer style lights that uses a low voltage controller. So this actually converts the power down to roughly 30 volts and has a little button on the end. So it does something kind of interesting with the output. But let's go ahead and plug it in. There it is. Wow, lights. So it lights up. It's reasonably bright. It's not too bad. You know, it looks like we got 5 different colors of lights here. They're all, or 4 different colors, sorry. 4 different colors of lights. Looks fairly basic. So what I have set up over here is it's actually a light sensor. This is an Adafruit sensor. I'll go ahead and put a little overlay on this one, and then I'm actually going to put an overlay on for the newer version of this too. So they actually don't make this sensor anymore, but I just have it on a little breakout board powered. So you can see right now, if I cover this up, you'll see the multimeter voltage drop a little bit, and then if I open it up, it'll do that. So one thing I have is a tiny cup here. We can cover that up and see that the voltage drops down to a very, very low level, which is, you know, because we have a lot of light on this bench. So so inside of this cup is just white, so it's going to be pretty reflective. So if we shine that light in there, so I'm just going to grab one of these lights and push that inside there, cover that, a little slot cut out here so I can get a good seal at the table, and see what we get for a reading. And so these lights work on a pretty interesting principle. They actually switch the polarity back and forth on this output here. So these are actually still fairly flickery, even though it's using a DC power supply to send the voltage out to the bulbs, and they're actually PWMing between the two sides. So it's something pretty interesting in the waveform for this, and we'll show that. And we also can see that the way that this thing consumes power is over really, really short, narrow spikes. So it's very low power factor, considerably poorer than a lot of typical bulbs. Let's take a look at the next one here. Blingstar. It's another set of 100. This one's got green. It comes with little instructions. It's got a box, not just a bag. And same style. So you got that little power adapter. Expect these to perform very similar to the last ones. Oh, alright, they're on. These are actually, in terms of my observation of them, they appear a little bit more dim. They still don't look too bad though. They look pretty good. I got to separate one of these out. These are going to be using the same style as that last bulb. You see the power consumption is just slightly higher, still terrible power factor. These are all using the same basic technology. Cover one bulb in there, and so just extremely similar to the Zunstar, the Blingstar. Looks exactly the same in terms of its waveform. So you have a huge spike, so it's drawing a lot of current for a very short period of time, very poor power factor. and the output is that same style. It's actually a little bit higher frequency on these ones. These are oscillating at 250 hertz. Okay, time for the next victim. So here we have some GE Stay Bright 100 LED, miniature LED. These lights are a little bit different than the previous one. They don't have any separate controller, so let's open them up. You can immediately see the packaging's a little bit different. We get some spare bulbs, we get some spare fuses. We have a lot of instructions, which I'm not going to read. And wow, the bulbs are just totally different. They look like large bulbs. Let's go ahead and plug these things in. And the first thing I can tell is these flicker like mad. They're pretty extreme, but one of the things I noticed in our power analyzer, yeah, they're using a little more power, but our power factor is substantially better with these. And you can see that there's no specific rectifier in these, so oh, there it is. So you have a little diode hidden right there on each set of the strings. So there's just they're hiding a extra component right in here, and I'm not sure if they put any resistors in these, or if they're just the raw LEDs themselves. So separate out a bulb, get it into our light sensor, and we'll take a look at the scope. So this is definitely a very different graph. The frequency is much lower for the light output, which is expected. So we see it's obviously matching the sine wave. Also, the power consumption graph is looking much more close to the sine wave as well, since the LEDs start drawing power, basically once they conduct voltage. So you see there's a little bit of flat spot on the curve, but then it actually has a little, it's still a spike, still not sinusoidal shaped, but it's substantially better than the other lights. But like I say, these flicker like crazy in terms of the appearance to the eye, because it's about 60 hertz flicker rate. Okay, the next one's up. So these are GE 100 miniature lights. So these are going to be incandescent bulbs, old school. Let's open that up. Very similar packaging. We get a few spare bulbs. Get some instructions. Green and a red, of course. And pull these out. So first thing we notice is the colors look a little more deep, because they're actually painted bulbs. So these are all the same color bulb, and they're all just painted. So let's go ahead and plug this in. I may have to change the current range on my oscilloscope for these. So first thing I notice is the power consumption is huge. I can actually feel these getting warm just by holding them right here. And you can see the power factor is 1, so that's good. That's a plus. But you can see it's using 38.4 watts. So serious power for just 100 lights. And let's go ahead and separate one of these out. And we'll take a look at it on the light meter. Alright, so as expected for this, the output does have a tiny bit of a movement in the waveform, but it's almost an exact straight line. It's almost perfect DC. There's really no fluctuation, which is what you would expect from an incandescent bulb. So these don't have any visible flicker at all. They just look like they're on. And according to the sensor, they're literally just on. So there's no flicker at all. The current waveform and the voltage waveform are both perfect sine waves. They're exactly in phase with each other. It is exactly what you would expect from a incandescent bulb. Okay, time for a big string of lights. This is a Philips Easy Storage Spool 250 mini lights. These are incandescent, and they come with little flasher thingies and some spare bulbs and fuses. They're actually pretty good in terms of supplying a few pieces of equipment with them. See, they unroll really easy. They got some instructions in there. And I expect these to use a lot of power. And there they are. They're using a lot of current. A lot of power also. For 250 lights, we're at 57.1 watts and 0.481 amps. Again, that power factor is 1. So that's looking really good. But man, 60 watts just to power a string of lights is kind of a lot. So let's take this guy, get it on our light sensor, and let's see how much light we get out of it. See what the waveform looks like. So same thing on this one. The light output, pretty much a flat line, so there's no visible flicker at all. They just look like they're on, which is great. Reasonable light output. Nothing to say about that. In terms of current and voltage, they're both perfect sine waves. Obviously the current waveform is pretty substantial with this one because it is using a lot of current. It's not great, but then again it's 250 bulbs, so we'll see how it does compared to that GE incandescent set. Obviously the current per bulb for any of the other ones is going to be substantially higher. Alright, here's the next one. Got a Philips 100 warm white LED. It says 82% energy savings. We can do that math. Wow, they look, they really stuffed this one in the box. Oh, we got some little kind of pattern on those. They don't look too bad. Again, they give us a couple spare bulbs, spare fuses, some instructions. Oh, yeah, those are hard to look at. So these are a flickering nightmare. Yeah, it's unfortunate. But they are. Yeah, they're terrible. These might be the most flickery ones yet. You can see the power is a little higher, so you got about 4 watts for these. Power factor is actually not bad again, so it's that 0.91. I expect we'll see a little spike, and we'll see mostly it's drawing current over a fairly large part of the waveform. Yeah. Let's get one of these separated out if we can and check it on our light meter. So extremely similar to the GE 100 LED set. The light is following the 60 hertz wave, it's half wave. So every 60 pulses you're getting a set of output. And I didn't see a diode anywhere hidden in here, but I'm assuming there could be one in the string. There may actually not be because these are all diodes, so really you don't need to put another rectifier in there if they're... These may actually damage themselves if they don't have any reverse protection, basically, is what can kind of happen, but they might be okay. These are really, really flickery. Probably the worst. I don't know if that comes through on the video, but they are hard to look at. Again, we got that 60 hertz frequency for the flicker. Current waveform looks very similar to the other sets. The other LED, GE LED set rather. They're not the worst in terms of that part of it, but they are really hard to look at. All right, here's the next one. It's comes in a little box here. It's got a label on the side which doesn't match the packaging or the label that I bought. It does come with a little card that says thank you. That's nice touch. And these are 200 LEDs. I can't pronounce the name of the company. You can read that on there. Same thing, comes with a little power adapter. Got the little button on the box there, so these are working the same way some of the previous ones. And first thing I noticed about these is they're very dim. They are not bright at all, and for the amount of lights you're getting, it's not very bright. I wonder if you can see the flicker. These do have some visible flicker just from looking at them, and they're very low power, so 2.34 watts for 200 LEDs is just it's not giving out a lot of light. 0.5 power factor from this little power supply is what you'd expect. And let's go ahead and get this on the light sensor and take a look at what we get. So in terms of our waveform, we got a giant spike for current, and yeah, that's not a surprise, but this one is actually flickering at a pretty low frequency compared to the other one. So we're seeing 140 hertz per LED side. So these are like say they're wired a certain way where they actually flip the polarity back and forth. It's that same style. Right. So I don't know. This one's probably not a win in my book. Okay, on to the next one. So this is multicolor 300 LEDs Twinkle Star. Seems like it's got kind of a name brand. Comes in a nice box. Giant pile of LEDs. These are really 100 lights per piece. Let's see if we can find if there's an output connector on any of these. Doesn't look like it. So these, yeah, you can only run one of these sets or one of these power supplies. Yep. So one set per power supply. Plug it in. So this is a little bit different. This power supply over here doesn't actually have any buttons on it, but it is still a very similar rating, 29 volts, 0.2 amps it says, which is not drawing anywhere near that. And another thing, so first note on these is they're dim. Also, they flicker. So it's got this little control box here. This is actually doing that that function I was talking about where they flop the polarity back and forth to get 300 LEDs, and we're 2.5 watts. Ah, man, it's just stretching it a little far. I mean, yeah, you'll be able to see them, but they're not very bright. Let's go ahead and grab one of these LEDs. Get it over here for our light measurement. Okay, so these actually have a little bit of a higher frequency they're operating at, about 318 hertz. So that's actually good, but the flicker is still visible for some reason. So I don't know if it's just an artifact or not. In terms of overall brightness, they don't look too bad. The power supply, again, is just a gigantic spike. So it's just drawing all its current really short, really fast. So yeah, if you had a lot of these all hooked up at once, it's actually not so great in terms of how it's going to treat your panel, your electrical panel, things like that. But yeah, that's about it. Okay, I just want to shoot a quick part of the video going over the different modes that these lights have. So right now he's steady on. This is what they call in waves, but it looks like it's just off. This one is sequential, so it's just going back and forth between the two, and it is fading in and out. That one doesn't do anything. You have slow fade, or this is chasing flash. This is actually swapping between the two sets of bulbs, and they're steady on during this time. Oh, it's okay, so it's doing a couple different things. One thing you notice is that when the bulbs are steady on for a longer period of time, they're actually brighter, quite a bit brighter. They look substantially better during one of those modes, but when it's flipping back and forth, turning all the lights on, they look a lot worse. This is on fading modes. This is just a little bit of flickery, flashy things. There goes the multimeter. And then we got a fade in, and then another flickery mode, and then we're back to steady on. So here we have the overall performance chart. And you can see all the data from all these different lights collected, and you know, kind of just presenting them. You know, one, we have the cost per bulb, and we can see that there's a couple of bulbs that are definitely, you know, definitely a couple of sets of lights that are definitely more expensive than the others. We can see the Philips LED bulb and the Blingstar LED bulb are the most expensive type, and in terms of the winner overall, I'm considering the Blingstar to be the general winner here. If you look at it, it has a very low power consumption. It's got a reasonable output light shape, so it doesn't look too flickery. The biggest issue with this one is it does use a lot of current, has a large current spike, but because it's using such a small amount of power, that current spike is still really small in general. So overall, this one, reasonable brightness, just ended up being the best of the bunch. So I'm looking at the power consumption graph. We can see that for the most part, all the LEDs are pretty much on par with each other, but the incandescent ones stand out quite aggressively here. So the current consumption graph we have here shows the first four, the four with the lower power factors. So these graphs look a little higher, and then the last four had good power factors, and you can see that they're all you know, a little bit higher in general, because they all did use a little bit more power. But you see the two incandescent ones are way higher, so they're using a lot more current to power the light bulbs. But the one thing to take into consideration here is those first four with the large spike, their peak current is actually very close to that of the incandescent bulbs, because they're using the current over a very, very short period of time. So, you know, in terms of efficiency for grid use, things like that, they're not fantastic. But you know, there's some trade-off there. Can't win all the battles. Just a little bit of math, so we can see, you know, why buy LED lights and can it save you money. So here's just the average values of all the sets that I measured. So the LED string per 100 bulbs, you know, just assuming you're going to use them for about 6 hours a day, 40 days you're going to use them for. We have our cost per kilowatt hour. So the energy consumption is about 2 watts average. We're going to use about 3.2 kilowatt hours over those 40 days. It's going to cost us about 64 cents to run those lights. Same thing for the incandescent bulb. It's going to cost us about $9.82. So, you know, you're looking at, you know, if the LED bulb costs more than $9 more than the incandescent one, then you're saving money. I mean, you know, first season, assuming you get more than one season out of these. A lot of times they break, so some people throw them out every year, stuff like that. So, you know, the more seasons you use these for, the more this compounds and you save even more money. So if you can keep them in good condition and use them for multiple seasons, you can save even more money. But yeah, just for this quick analysis here, you can see that just for right now, if you go out and buy a set of lights, use it for 40 days, you don't want to pay more than $9 premium for those LED lights versus the incandescent ones. Okay, so after looking at all the performance metrics, the Blingstar string lights, Christmas lights, appears to be the winner. So you get reasonable brightness, reasonably low flicker level. It's got the pass-through, so you can connect more strings of lights. They don't use a lot of power. The biggest issue with these is they do still have a little bit of flicker, but it's not bad, and they have a terrible power factor. They draw all their power in a big spike. So, you know, a little bit of work to do. So these could be the perfect set of lights if they do a few things differently with these. Basically work on this power supply, you know, make this thing a little bit better, and I'd want more of these. Thanks for watching. Like and subscribe, and if you want to see more content like this, leave a comment down below.